In this tutorial we're going to cover basic character creation. Now, working within a production pipeline, usually you will have your character already set up, so naturally you want to have that character within Endorphin. We can do this very easily by modifying the Endorphin character to fit your pipeline. Then we use the auto motion transfer to load animations in and out of Endorphin. So to do this, first of all we load in a file of that skeleton. In this case it's going to be an FBX file, and then we go through and we reshape the Endorphin character to fit that file, and then we associate the body parts of that external character to the Endorphin character, and then finally we use the auto motion transfer to load an animation onto that character. So to begin with, we're going to go into character edit mode and load in a file that we can then use to reshape the Endorphin character to. So we go File, Character Edit Mode, New Character. This brings up the New Character dialog. Now this is split into two sections. This is the simulation character and this is the reference character section. So for the simulation character, we want to base it on the standard simulation character, which is the guy that we see here as default, and then we want to turn on reference character, and this is where we select the external file. We click on Browse and want to go to Tutorial 5, Creating Characters Basic, and load AMTpose FBX. Click OK. We want to select the hips, as that is the root of our character, then leave everything else as default and click OK again. Now that's brought us into character edit mode, and as you can see it's a little different from standard scene mode. First of all, there's no timeline. We're not working in any aspects of time. We're purely just setting up the characters. There are a few tools that are different on the top toolbar. First of all, you can see that there are two buttons here that are extra. This is to switch between the simulation character and the reference character. So if I do this, I can select the external FBX that we've just loaded in. We'll go back to the simulation character. For now we want to keep working on the simulation character, as that's the character that we're going to modify to fit the external skeleton. And then we have these additional tools here for mirroring whatever changes we made from left to right, and then also to mirror selected. So to begin with, we go into skeletal view, and now you can see we've got the two skeletons that are almost matching on top of one another, but we need to modify the simulation character a little bit. So the reference character has been greyed out as he is not selected at the moment, and that also makes him not selectable in the viewport. First of all we select the hips and just manually move that into place, and then we can snap the rest of the joints. Now snapping works by selecting the purple square in the middle and then moving it over the joint of the reference character, then it will automatically snap into place. So we can continue down the leg. Now as you can see here, the simulation character actually has an extra joint for the foot. It has 3 joints to allow for better foot roll, but the reference character does not have this. So in this scenario we want to set this up correctly. So we go to the left view, zoom in. Now we want to move this down vertically so that it is in line with the ball of the other character. Then go back into perspective and then just snap the other ones into place. So that's the kind of setup that you want to use when you're using a two-boned character. So once we've got the left side all done, we just hit mirror left to right, and that puts it over onto the other side as well. Now working our way up the spine, first of all we select the first joint and snap that into place. And again you can see that the simulation character has an additional joint here, so we just leave that halfway in between and snap the next one into place. Select the neck, snap that, the head and the head end, and then going down the arm, snap the collar into place, shoulder, elbow, and again you can see we've got an extra joint here for the forearm roll, so we again just leave that halfway in between and then snap the wrist, leaving the hand as it is because the reference character doesn't have any fingers. So mirror left to right, and there we go, we have the two skeletons matching up. So we go into shaded mode, then we can see that we've got two characters matching. Now one thing that we do need to modify slightly is the feet. Because we moved that ball joint down, the actual mass and collision objects of the feet are now angled up a little bit. So we can easily do that by rotating the mass object. Now this is easier if we hide the reference character so we can clearly see what's going on. We can do that by bringing up the node view, that's hotkey N, and then select the reference character, go hide all, and then go back to the simulation character again, and then hide the node view again. It's just hotkey N again. So we select this mass object, go to the left view, we want to rotate it so that it's back horizontal again. Now as you can see, these collision objects are actually off the ground now because the reference character's foot was higher up, so that means that he's actually going to not be on the ground when he first starts the simulation. So we want to fix that up a little bit as well. First of all, move these down so they're in line, and then to make it easier to select these collision objects, turn off the character cube, drag a box over those collision objects and move them down so that they're all in line, and move those heels down a little bit more as well. Once we've done that, again mirror left to right to get it over to the other side, back to perspective, and there we have it. We've got our character set up matching the reference character. So what we need to do now is associate the joints, well, the mass objects of the reference character to fit the mass objects of this character. So we go back to the reference character, show him again, turn the node view off again, and now we go to character rig setup. This is where we make the connection between the rig nodes of the simulation character to the mass objects of the reference character. We're going to use this section here, the rig node mass object connections. I'm going to start with the root, and that's going to be the hips of the reference character. The lower spine is going to be chest. Now if you remember, we didn't have a mid-spine joint, so I'm going to leave that clear. Go to upper spine, chest 2. Head is going to be head. Right shoulder, in this case it's called collar on the reference character. Upper arm is shoulder, hand is wrist, and then the fingers, again, there weren't any on the reference character, we're going to leave that blank. I want to copy over onto the other side. Hand, wrist, and now for the leg, the upper leg is going to be hip, foot is ankle, toe is foot, and then again on the other side. So now once we've got all those associated, we can now click OK to confirm our selection, and then go back to character editor mode, save character, and simply name it my character, and click OK. So now that we have our character set up, we can go into a scene mode and load an animation onto that character. So we go File, New Scene, the timeline comes back again and we're back into scene mode. Select the default character, delete him, go to Add Character, and then click on My Character. We then select the character, go to Import, go to Resources, Animation, Audio Motion 1, FBX, choose any of the animations here. I'm going to pick the Run animation, and then in the Auto Motion Transfer section, turn it on to activate it, then click on Browse, choose My Character as the reference character, click the hips, and then leave everything else as default, and then click OK, and then the motion will be dynamically transferred onto the simulation character. And there we go, we now have the simulation character being driven by the external animation. You are now free to use all of Endorphin's features to enhance the motion using behaviors, active poses, forces and such forth.